All right. How's everybody doing this morning?
I'm good.
That's good. All right, so y'all remember what we did last class? Anybody? Is it too early for y'all? Yes, Alex, that's right. Reading and writing text files. That's exactly what we did. It is early for y'all. I remember what it was like to be in college. 8:30 is a little early. But we got to do this. All right, so yeah, last time we did reading and writing text files. We're gonna pick up where we left off last time. Too tired to make breakfast in the morning. I understand that. All right, so let's open this, and we'll talk about where we left off last time. I think, and correct me if I'm wrong, I want to make sure we start in the right place. Last time we discussed the basics of raising my chair. We discussed the basics of how the meals were stored in terms of reading and writing. I think it was in meal database. Okay. So we looked at reading and writing to files for just the side items. Okay, so we had files, and then we were writing this dinner sides text file. I believe that's correct. And so what we talked about was if you need to write to a text file that you know already exists, or you are writing to a specifically named text file. Like, for example, we are hard coding the name of this text file as dinner sides. Like that is created in the program itself. This is not something that the user creates. We have predefined that this dinner sides text file is going to exist. And so what we are doing is we are explicitly creating a path to that file. All right, and we are reading and writing to that file. And so let's review that quick. And then what we'll do is we'll get into how to handle the situation where we need to create an unknown number of text files and have them named based off of something that the user is doing in the program. So the user is essentially coming up with those names, and we don't know how many of those we need to create. Depending on the program that you have, you're probably going to do one or the other. Okay, and so let's take a look at this. The first thing that we've got, and this load database gets called right when the program starts up. And what we're doing is we are creating a path. This is a string path to where the files exist. Okay, and so depending on the application that you're using, either Java or C#, you need to figure out a way to get access to where the program is being run from. Okay, and here we're just using application.datapath. I'm using substring to pull out everything except the very last section. And then we are appending onto that files. Okay, and so that's essentially how we get right here. This is C. I've got my stuff stored inside a folder called game development, and then the name of the project, and then a special folder called files. So if we go back here, this is how the main project is set up. And I created this folder myself called files. This is not a part of the normal library or not part of the normal project hierarchy. I created this folder and then created all these things inside of here to store the data. Okay, so we create a path to this files folder right here. And then I create a new one called path to meals. And this is what we'll talk about later today. And so let's review load sides real quick. Okay, so we take that path to files string that gets us access to this directory. And then onto it, we add dinnersides.txt. Okay, that's what gets us specific access to this file. So before, the path to files gets us access to this directory. And now we're specifically referencing one file inside of that directory. All right, that's how you do it. You just simply add on to that string. All right. And then this is how we actually read. Okay, file is a built-in part of the system package. If you're using C#, you'll have access to this in Java. It might actually even be the same thing, but I don't know off the top of my head. Anyways, this is how we read text files. It's just file dot read all text, passing in the string, which is the path to the text file you want to read. Okay. That's going to store everything inside of a string variable called contents. And then what we do here is we use the split method of the string class to split that entire string, which the entire string is all of this. This is one string. It gets read in as one string and stored inside of a variable called contents. And then what we do is we declare an array of strings, and then we split the entire contents based off of line breaks. That's what this does. We split it based off of line breaks. All right, and there's different, there's overloaded methods to this. And so this is what we're doing here. The character that we're using as the separator is a line break. And then we want the very first one, which is what we've got here. Okay, so we split it into lines. And so that puts each line of the text file in its own element of the array. So asparagus is at position 0, baked beans is at position 1, cabbage is at position 2, and so on. And then what we do is we loop through that array. So we loop through every item it loads, and we make sure, as long as it's actually reading something and it's not a blank line, then we're going to add that item to our list of dinner sides. And then at the very end, we sort it by name. That's how it works. Questions on that? Okay. I'm assuming everybody's good or everybody's asleep. All right. So that's how we load the sides into the program. So it reads this text file, which exists externally from the program, reads it in and stores it. Now let's look at writing. And so we're going to go write side items to file. So whenever we have a change to side items and we want to override that text file, here's how it's done. Again, we create a path to that dinner sides text file. Okay, so we get access to where that file exists. And then we do the opposite of what we did before. So if you remember, when we read this into the program, we did file dot, is it read all? File dot read all text. Okay. And that takes all of this text and it stores it into a single string. And so we're going to do the opposite when we write. We're going to take the individual lines, asparagus, baked beans, cabbage, corn on the cob, and so on. We take those individual lines and we combine it into a single string. And that's what we do here. We start off with combined sides as an empty string, and then we loop through the list of dinner sides, and we concatenate it onto it, adding a new line each time we add a new side. And so this creates a single string that represents the totality of all of the dinner sides that we have. Okay. And then what we do here is we actually delete the original text file that exists in this directory. We go ahead and delete it. Okay. And then as soon as we delete it, we create a new one with the contents matching whatever's in this combined sides. Okay. So effectively, we are overriding it. If you look at technically what we're doing, we're deleting and then creating a new one, but it happens all at the same time. And so it's effectively just overriding the one that's there. Okay, but that's how it happens. And that's what we did last class. That's a review. Questions on this, on reading and writing to a single text file? Yeah, so we're overriding it to update it. That's exactly right. All right. Any other questions from anybody else about what we're doing there? Is that how real updates work in layman's terms? Not necessarily. I honestly don't know if this is what I do. Here's Access Football. I don't use text files in Access Football. I actually write yeah, I'm not sure. I know, I'm pretty sure there's a way to update a file. I'm looking to see what I do here because I honestly don't remember. This is the code for when we save locally. File.create. So this is how I save in Access Football. I pass in the path and I pass in what we're saving, which is a save game data object. And I'm actually serializing it, which encrypts it. But you can see here the code. The code is very simple. This is how this works. I want to look at this file.create. Hold on. C# file.create. I think the create method will override it if it exists. Yeah, that's what I thought. So in C#, if you use file.create, it will override a file in the specified path or creates it. So if it exists already, it will override it. If not, it will simply create it. So this is another way to do it. Just use file.create. And that's what I do there. And then we serialize it here, which is this is what encrypts it. And then you deserialize it when you load it in. Just load data. So if the file exists, you open the file and then you deserialize it because let me get to where this stuff is stored. Users, app data, local. So here's the actual saved game data. I have them stored as .dat files, which are just so serializing and deserializing is essentially refers to when you serialize something, you're putting it in a format that can be read by a particular system. And this is essentially what encrypts the data. So I've got it encrypted in a way where even if you were to open this file, So this is franchise data, for example. This keeps track of all of the season data that you have over multiple seasons is stored here. And franchise data 0 is the very first slot. So even if I try to open this, where's open? Open with where's Notepad? This is what you get. Okay. And you can kind of read it, but you kind of can't. This is encrypted. This is serialized. And so when you serialize it, you kind of change the format of the text. And then to deserialize it, you're basically doing the opposite. So we took it from, essentially what I'm doing is I'm saving an object to memory. And then when we deserialize it, we load it back into the program. And if you look at this line of code right here, we are deserializing the file, which is what reads it back in. And then I'm specifically typecasting it to the type of object that I know it should be, which is a saved game data object. So we have, the way I've got this set up is it's an inheritance structure. And so everything that gets saved in the game is a saved game data object. Okay. And so all of the things that are shared among every saved game file, I put here. So every saved game file has a file name. It's got a timestamp, a game version, username, and then this is something different. But then what we have is we have specific types of files that get saved. So for example, we were talking about franchise data. So let's look at franchise data. So this is public class. SGG is just my naming convention that stands for saved game data. So I know what this is. And then notice the colon here. This, if you remember in C# specifies inheritance. And so we are inheriting from saved game data. So this is a specialized type of saved game data. So it includes all of this information, file name, timestamp, game version. But it also includes information that is specific to what we want to save for franchises. And so all of this information gets saved. Okay. Also, and one of the cool things, and this is kind of an advanced saving and loading system, but what we can do here is instead of writing to a text file, we can actually save entire objects, which is beneficial because if you look at this and you think, okay, if I wanted to save, let me actually look at a more basic example. Let's look at game settings. Okay. So here are all the game settings in the game, like the sound effects volume, the announcer volume, the options menu volume, whether or not you want the sound on, the music on, graphics quality, resolution, all the sort of things that are game settings that you want to save. Okay. If you think about it, if you wanted to save this, what you would have to do is write all of these values to a text file and then load them back in. And then when you load them back in, you would have to go through and set all of these variables, which would be quite a lot of coding. But what you can do is you can actually, if you put this serializable tag above the class declaration, you can actually write this object to memory. Okay, so you create an object of SGD game settings or whatever the name of your class is, and then you can physically write the object that you created to memory and then load it back in, and the object exists as an object. You don't have to load in each individual line from a text file, and it just makes things a lot easier, especially as you have more complicated objects. For what you guys are doing in this project, writing to it from a text file is fine because you're probably not writing a lot of data. But if you had a really complex object and it would be really cumbersome to write, you kind of have to like break out all of the data from the object into a text file and then read it all back in. Especially if there's logic associated with the values of variables, that becomes quite time consuming. So this is a more advanced way to do it if your objects are more complex. Okay. All right, so back to this. Any other questions on writing to a single text file, writing and reading to a single text file? Okay. And if you want to do it the other way, like if in your program this semester, you happen to have some rather complicated or complex objects that you would like to write to memory, just look up C# serialization, and Java may have it too. I don't know off the top of my head. It's not like the coding is not more complex, it's just different. And you saw the code in Access Football. It wasn't much more code than what we saw. In fact, some of it was more simple. It's just a different way of doing it. Okay, so that's how we write to a single text file. Now what I want to look at is how we write when we don't know how many text files we need to create, or we need to be able to create text files on the fly, on demand, while the program is running. And so I'm going to run meal maker just so that we can have some context. And then I'm going to go into meals menu. Okay, and what we have in this menu is these are all of the meals that we have created. And if you remember, meals have several components to them. If we look, the name of the meal is always the main dish. Okay, and so here we have burgers. We have burgers here, and then so burgers is the main item in the meal. And then we also specify sides. Some meals have sides, some don't. Some meals have 1, 2, 3, however many sides go in the meal. It's a different number. So if you look, for example, tacos themselves are a meal. You don't necessarily, at least in our house, we don't have a side with taco, because tacos kind of have all of the sides included in the taco themselves. And so we don't have a special side for that. Okay. For burgers, we typically have 2 sides. And then when you look at the sides that you have, excuse me, let's look at burgers, for example. We check all of the sides that would go well with burgers. Okay, and so, for example, baked beans would also go well. Even asparagus or corn on the cob, all of those would go well with burgers. And so we essentially check all of the different ones that would go well with burgers. You wouldn't probably have rolls with burgers unless your family just really, really, really likes bread. But that's the idea here. So we said we always want to have 2 sides with burgers, but we're going to pick from 7 different options to create those 2 sides. That's how that works. Okay, so each meal is set up like that. And the idea here is we want to store each of these meals in their own text file. Okay, you could, I suppose, you could create a single text file that held all of this information, but I don't think that's as elegant of a solution. It makes more sense to have each of these meals stored in their own text file. And then we will load those in all together. And then when we go to add a new meal, that would be a situation where we would need to add a new text file to that. Okay, so those are all of our meals. And those meals are stored inside a separate folder called meals. And here we see all of those meals represented as text files. Okay, inside of the text files, we see that information that we have. So we have burgers, dinner, 2, asparagus, baked beans, and then we see them listed here. Now, we don't know what these mean. And so there's a couple things that you can do. Excuse me. When your text files represent more complex data like this, when we're looking at this text file, we could probably puzzle out what some of these things are, but we're not entirely sure. So for example, burgers, okay, that makes sense. That's the name of the meal. Dinner, well, maybe this specifies the difference between a dinner menu and a lunch menu. And then we have 2 and 2 here. I don't have any idea what this means. Okay, one is probably how many sides, and one is probably the frequency, but there's no way to distinguish between those two. And then this is probably a list of all of the available side items. Okay, and so you can do a couple different things here. If you intend for the user to have access to these text files and you want them to update them, then you might want to make this a little bit more readable. Okay. But you don't have to do that. You can just have it set up to where the program knows the order that these things should appear in. And for simplicity's sake, let's just leave it like that. If you guys are interested in making these more readable, I can show you a better way to do that, but it's not necessary for what we're doing now. Okay. So let's get to the code. We're doing this. Excuse me. All right, so we call load database at the very beginning. All right, and we know this gets called once, right? And when the program loads up, and then we have two things here. The path to files we know gets us access to this directory. Okay, it gets us access to the files folder inside of where the project is stored. And then we have this second variable called path to meals. And all we do there is we simply add on the string to where to find this meals folder. Okay, and so path to meals now holds this string, the C:/game development /meal maker /file /meals. This gets us access to this folder right here. Okay, we already looked at load sides. Now let's look at load meals. Right, it takes us to this function right here. So here's how this works. First thing that we're going to do is we're going to create an empty list of meal types. Okay, so this is a list of meals. Meals are a class that we have created. We'll take a look at those really quick. Okay, so public class meal, name of the meal type, whether it's a dinner or a lunch item, the number of sides, the meal frequency, and the side items. If you remember, the meal frequency is used to determine how popular the meal is. So the higher the frequency value, the more likely that meal is to show up on the calendar. All right, so if it's something that your family eats a lot, you'll give it a higher frequency. If it's something that you only want every now and then, you'll give it a lower frequency. That's what that is for. Okay, let's get back to the code. All right, and so that is the meal. And then we have a print meal function, which simply prints out everything. This is kind of like a two-string method, just so for like testing purposes, you'll see here this 0 references means it's not actually called anywhere. It's just something that I put in for testing purposes. Okay, so pretty simple. That's our meal class. Every meal we have in the project while the program is running is going to be represented as a meal object. And so we have a list of meal objects here that we are going to use to store all of the meals that get loaded in. Okay. Now, some new code right here. We have a string array that we call list of meal files. And we are populating that with directory.get files. Okay, directory, again, is built into C#. And what get files does is it returns a list of all of the files found at the specified directory. So if you remember, this path to meals, up here, path to meals is a string that equals this directory right here. Okay. The C:/game development, blah, 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 all the way to meals. This is this directory right here. So when we call directory.get files, when we call this line of code right here, it returns a list of all of the files found in this directory. Okay, and so this should give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items. And so our array of strings would hold burgers.txt, cornedbeef.txt, herbchicken.txt, and so on. Okay. Everybody good so far on what we have? So list of meals holds a list of all of the meal files found in this directory. Okay, that's how we can dynamically populate this with all of the files that it finds there. Any questions so far? Okay. Now, what we're going to do then is we're going to loop through that list of files. Okay, and so we use a for loop because we know exactly how many times we want to loop. Start at 0, we go all the way through the length of that array that populated. And here's what we do. Excuse me. I'm going to break this into 2 separate lines of code to make it a little bit easier to read. So we're going to say meal. I'm going to call this new meal equals new meal, like this. All right. Now, before I just had this all done in 1 line of code, I'm going to separate it here to make it a little bit easier for you guys to understand. All right. So what we've got right here is we are declaring a new object, and we are setting that object equal to the results of this function. Okay. And this function right here, it says create meal from text file. We notice that if we mouse over this, we see right here, it returns a type meal. So it's returning an object, and we are passing in a path and file name. Okay, so what we're doing is we're looping through that list of strings that we populated from the directory. Okay, so the first time we run through this for loop, the first iteration, we're going to say list of meal files at position I, which is position 0. That's going to pass in burgers.txt. Okay, in fact, it's going to pass in the entire directory. It's going to pass in C, game development, meal maker files, meals, burgers.txt. That's what it's going to pass in. Okay, so it knows how to exactly access that file. It's going to take that text file, it's going to create an object out of it, and then return it here. Okay, so let's take a look at what this function does. All right. So we have passed into this function the exact location for a particular meal text file. So the first one is burgers. All right, so let me pull this right here. Move this right up here. All right, so we say string contents equals file.read all text. We're familiar with that already. What that does is that takes the entire contents of the text file and it stores it into a single string variable. All right, like we did before, we want to divide up the contents of that string variable into separate lines. And so we use the same line of code to split that entire string into separate lines. Okay, and so burgers is going to be at index 0, dinner is going to be at index 1, 2 is at index 2, and so on. Okay, now what I have here is I declare a variable that keeps track of the index in this text file where the side items start. Okay, it's just makes it a little bit easier to read. And so if you look at this, what that does is this keeps track of where each line is. Okay, and so this is index 0, this is index 1, this is index 2, this is index 3, this is index 4, and so on. And so our side items start at index 4. All right, and so what I have here is I'm basically hard coding what to find at each index of this text file. Okay, and so right here, declare variable meal name, and we set it equal to lines at position 0. Okay, notice the comment, line 0 is the name of the meal. All right, declare another string variable type. This is the meal type, it's at position 1. Now, this is a little bit different. If you look here, we are declaring the number of sides and the meal frequency. You have to, because by default, C# is going to read this in as a string. And so this is going to be read in as a quote to quote, okay? 2 as a string, not 2 as an int. And so what we need to do is we need to convert it to an int. And that's what this does right here. This int.parse takes a string and converts it to an integer. All right, that's the purpose of what this does here. And we simply do it twice. One for the meal frequency and one for the number of sides. And so this is what I meant earlier when I said you can tell the program explicitly how to read these text files. And so when it finds line 1, that's going to be this. When it finds line 2, that's going to be this. And so that's exactly what we've done here. The first line is always the name of the meal. The second line is always the meal type. The third line is always the number of sides. The fourth line is always the meal frequency. Okay, good so far. Okay, and so we have those 4 variables stored. Now we need to handle the side items. So we don't know how many side items there are. There could be 0, there could be 100, it could be unlimited, really. And so we're going to use a list. We don't want to use an array because we don't know how many they're going to be. A list makes more sense. All right. Again, a list in C# is the same thing as an array list in Java. And so if we look right here, what we do is we loop through all of the side items. So we start looping not at 0, but at side item start index, which we declared up here to be 4. Okay. And so essentially what we're doing is we already have this text file separated by lines into an array. We have that done right here. Okay. Line 0, 1, 2, and 3 get pulled out already. So we want to start our looping at index 4, which is why we have that here. We're going to start at index 4 and we're going to go all the way to the end of the list. So basically we're looping from here all the way to the end of the list. All right. We skip empty lines just in case an empty line gets created or added to the text file. And then we simply add to our side items list anything that is found inside of the text file from index 4 on. Okay. And then you see right here, we are creating a new meal object. All right. So we say new meal, and this calls the constructor, and our constructor accepts the following parameters: meal name, meal type, number of sides, meal frequency, and then a list of side items. This creates a new meal, and then the object, specifically the memory location where that object exists, gets returned to where this was called. Well, where was this called? This was called right here. Okay. And so we take the object that was created by reading the information in the text file, and we store it inside of this reference variable called new meal. And then we immediately add it to our list of meals that we declared up here. Okay. So we do that repeatedly for each file found in the specified directory, which is this right here. We create a meal object out of the contents of the text files, and we add those meals to our list of meals. Yes, object-oriented systems. That's exactly right. At the very end, we sort the meals by name. So if you notice before, if you remember, I should say before, we sorted the side items by name. Okay, and dinner sides is a list of strings. Okay, think back. This is what we did last class. We sorted the list of side items by calling this function right here, dinnersides.sort. Okay. This sort method is a method of the string class. We know that because dinner sides is a list of strings. And so when we call sort, it's sorting it based off of the fact that these are strings. Our meal list doesn't hold strings, it holds meals. And so we can't simply call meal list.sort because the system has no idea how to sort a meal. Okay, a meal is an object that we have created and we have defined. Strings are something defined by the programming language. And so they already know how to sort a string by default. Okay, strings are a common thing, they exist, they're going to naturally sort them alphabetically. But if I said, I want you to sort this meal, you would probably say, how do you want me to sort a meal? Okay, and so for that reason, C# doesn't know how to sort an object that we have defined ourselves. And so we need to write our own sorting method. And that's what I've done here. Anybody know what the name of this sorting method is? Walt. That's a good one. You got me on that one. That was good. Sort meals by name. Yes, that is the name of the sorting method. Let me rephrase. What sorting algorithm is this? Anybody know? No, not insertion sort. No, not bubble sort. I think you two are the only two that are awake. Oh, Ishan's awake. Selection sort is the correct answer. This is selection sort. Now, yeah. Good job. Now, 4 bonus points. I'll give you 20 points on your midterm if you can tell me the complexity of selection sort. It's what? Not ON. Good guess. Anybody? N60. What? Okay, so ON plus 1 is the same thing as ON. Remember, you don't include constants in big O notation. The correct answer is n squared. This is quadratic time. As a general rule, if you have a nested for loop like this, it's going to be quadratic time. It's going to be n squared. That's true. So that all of you that put n squared get 20 points on your midterm. You ever heard of never nesters? What are never nesters? I like seeing who's awake. Y'all do know that we don't have a midterm in this class, right? Just making sure. Amir, what's never nesters? It's a coding system that some people use where they don't nest loops more than twice unless needed. More than twice. I don't know that I have ever nested a loop 3 times. That's like what? Cubic time? I don't even know what that is. N to the 3rd. Yeah, that's as a general rule, you should never do that. Yeah, that's either way. All right, let's get back to this. Selection sort is n squared. It's technically it's n minus 1 minus I. It's that type algorithm. It's not fast. Quick sort, merge sort are going to be n log n, which are much better sorting algorithms. But when I did this, I couldn't remember. I didn't feel like doing a recursive sorting method off the top of my head, and I didn't feel like looking it up. So I just did selection sort because I can code this one off the top of my head. Here's the deal. At most, you're probably not going to have more than like 200 meals that you need to sort, and any sorting algorithm is going to handle generally anything less than 1,000 items without noticing a difference. And so, knowing the best sorting algorithm is good, because there are times where you might need to repeatedly sort hundreds of thousands of items, and then it's going to matter. But when we're talking about sorting a handful of items, it doesn't matter which one to use. Like, no one's going to notice what sorting algorithm you use. And so I just did this one because it was quick and easy. This is selection sort, and what it does is it sorts based off of meal name. So it alphabetizes it based off of the name of the meal. And that's how that works. Okay. All right, so we go back here, and that's how we do. We load the meals based off of the main item in the meal. So that sorts the list alphabetically. Any questions on loading in? So the basic idea here is we get all of the files in this directory. We pass in each file contents one at a time. It reads the file contents, creates a meal object out of it, excuse me. Once it creates a meal object out of it, we add that meal to the list. And once all of the meals have been added, we sort it. So we end up with a sorted list of meals. Okay. Any questions on this process before we look at saving, writing to text files? Okay, so that's loading meals. Now let's talking about saving meals. So we have write meals to files. And so this gets called whenever we add a new meal, and this is why this is a really nice C# feature. I like seeing where a function gets called or where a method gets called. And this references right here is super useful. And so this method, this write meals to file, gets called twice. And so if you mouse over this or you click on this, it shows you exactly where it gets called. So it gets called once where, oh, it goes away when I mouse over it. When we add a new meal, we write to the files. And then whenever a side item gets removed from a meal, we need to update the list of meals. And so that's where this gets called twice. So let's focus on the first one. Whenever we add a new meal. And so this gets called whenever a new meal gets created and we pass in, excuse me, we pass in the meal that gets created. Okay. And you can see it right here. So this is the this is the function that gets called when either you add or you edit a meal. And so here's some input validation, making sure they actually typed in the correct things, like the name of the meal can't be empty. We must specify how many sides. And so it goes through all those checks. And if a valid meal gets created, then we call add new meal right here, passing it in the name of the meal or the meal object that we created. Okay. So the first thing that we do here is we check to see whether or not the list contains the meal already. Okay. This is an input validation check to make sure that somebody doesn't add like burgers twice, or making sure we don't have a duplicate entry. Okay. If it's not already added, then we're going to add it. Okay, so if it doesn't exist in the meal list, we're going to add it. And then right here, we sort the meals again. and then we write them to the file. And so we're going to look at this write meals to file, but notice that we call sort first. Okay, we want them written in order before we write them to the text file. Okay, so when we get to write meals to files, we know that our meal list is already sorted alphabetically, and we know that our meal list contains a list of meal objects. All right, everybody good so far there? Our meal list contains a list of meal objects that are sorted alphabetically by meal name. All right, so let's take a look right here at this line of code. What we're doing is declaring a variable called file name, and this, as we know, is populated by combining several things. Okay, and we look, there's three parts here. This path to meals is all the way to our meal file. Okay, and so we have path to meals equals this. Okay, that is what the value of path to meals is. And then you notice we add on to that the meal list dot meal name dot trim. Okay, this is essentially the name of the meal. Okay, so we are going to add on to that the name of the meal. So if we go to our meals, let me close out of this, and then, for example, we go into burgers. The name of this meal is burgers. Okay, and so again, we're inside of a loop. So this meal list at position I pulls out the first object in the list, and then we grab the name of the meal associated with that object, which in our case is burgers for the first one. Okay, now this dot trim is a built-in function to the string class that trims off extra blank characters. Okay, and so for example, if when the user typed in burgers, I don't need this, if they typed in burgers and put an empty space after it, trim would remove that space. Okay, that's all it would do. So this trim just removes unnecessary blank characters. Okay, so all we do here is we add on to it the name of the meal. Okay, so this is what we have here. We add on burgers, and then we add on .txt. Okay, three parts. First part is here, path to meals, and then we have the name of the meal, which gets pulled out from the object name, like burgers, and then we add onto it txt. And so what we get is this. Right here. This directory right here. All right, and we can see that matches up exactly with what we have. You look at that a second. So now that we have access to the name of the text file that we want to create, we want to go ahead and combine all of that. Okay, and so we have a combined string. Remember, this is the same exact thing that we did when we write to the side items text file. When we load in, so we go from text file to program, we get an entire string that makes up the contents of the text file, and then we break that string up by line into the program. When we write to a text file, we do the opposite. We have already separate lines, separate variables that represent different things about the meal. We want to combine those into a single blob, a single string, and then write that string to the text file. And so that's what we do here. We start with the meal name and then add a blank, and then add a line break. And then we add on the meal type, add a line break, add on the number of sides and a line break, and the meal frequency and a line break. Then we loop through all of the side items contained in that meal object, and we add that to the combined string along with a line break. Okay, and so when we finish here, combined strings holds the entirety of what we want to write to that meal text file. Okay, so when we get down here, we now have a single string that holds burgers, dinner, two, asparagus, and so on. It holds all of that. Okay. If the file exists, we delete it, and then we write alt text just like we did before, specifying the file name that we did up here, and then the contents of it. All of this is done inside of a loop that iterates a number of times equal to the number of meals that exist in the program. All right, and so this is how it writes an infinite number of text files based off of the number of meals we have. We have 15 meals, we write 15 text files. And that's it. That's how it works. Okay. Questions for me? Okay. All right, we will stop there. I'm going to put this up on Canvas. Is removing unnecessary space for improving runtime? You're talking about in the code, like why I remove the lines? No, it's purely for whatever makes sense for you for formatting. I have my own, like I put spaces here, just it's whatever makes sense to you. I like visually separating certain things, but I don't need a bunch of lines between them. It's just kind of what I like to do when I code. And so if I've got like a larger function, so I have a larger function, like for this, for example, when I code, I like to, if I'm declaring variables that are similar, I'll put them right next to each other. But if I'm declaring something that's a little bit different, I'll put a space between it. There's really no rhyme or reason, and it's purely just what I like to do. Everybody's got their own style of coding. That's why I do it. It doesn't affect performance at all. Yeah. There's a lot of optimization that you can do. Time complexity is based largely on loops, but there's space complexity is, which refers to memory, a whole nother beast. And space complexity can be just as challenging. It just depends on a lot of factors, like what device you're targeting when you're doing this. And so that's kind of way outside the scope of what we're talking about here. But if you have specific questions, I'll be happy to help where I can. All right, so I will put this up on Canvas so you guys can refer back to this as you are reading and writing. Let's look briefly at what we've got going on. So today is the 7th. We've done the first quiz and we've done the first milestone. The next thing that we have is the 24th of this month. You've got your second quiz on object-oriented programming. So if we look at modules, here's where we are. This is something that I want you guys to kind of look at your own. We've covered a lot of this already. But like I mentioned before, each of you kind of came in with different levels of understanding with regard to object-oriented programming. And so I don't want to spend a bunch of time covering these topics if it's really boring for you. So a lot of this is review, but at the same time, I want you to go through it at your own pace. If you know this stuff really well, you should be able to breeze through it pretty quick. If you don't know it so much, this is an opportunity for you to get like a refresher or get a little bit more information about it. It's also specifically referenced from a C# perspective. And I know that you guys took Java for object oriented, so this gives it a little bit of perspective there. And make sure you take care of that quiz. You don't have to wait until February 24th to take it. That's just when it's due. This is available to you now. Okay. So go ahead and get this done before too long. I'm going to add. Yeah, you're good to go. When I can upload this video, I will put it here. So this is reading and writing to text files. And then here's what we have coming up. We're getting to a point where I've given you guys most of the tools that you need in order to code your program, code your project, your semester long one. This was really the last big piece. The reading and writing to text files was kind of the last piece that you guys need. From here, each of you are going to get kind of a separate direction based off of the requirements for your program. And so I'm going to start giving you guys class time to work on your programs. And we're going to start that this Thursday. And so the plan for the next week is Thursday is a kind of a working day for you. We won't have an official class. Use that time instead to work on your program or review some of this other stuff. Next Tuesday, we will meet to start going over this UML stuff. Okay. And you will need this for your second milestone and your third quiz. Okay. So I would suggest between now and next Tuesday, go ahead and go through these, take the second quiz, and be working on your program, your semester long program. Next Tuesday, we'll pick up with UML and use case, and we can go from there. Okay. Friday from 9 to 10 a.m., I will be in office hours, virtual office hours through Zoom. And so if you want to chat about your program, you have questions, anything like that, hop in during that time. I'll be more than happy to do it. I will not be in our class on Thursday. But if you have specific questions about your program, just shoot me an email. Always happy to help through email. And obviously always go into the TA office hours. So tomorrow at noon, looks like every Monday and Wednesday at noon, Juhi holds office hours. So definitely check that out for questions on your program as well. Okay. Any questions for me before we wrap up? All right. Y'all have a good day. I will see you.
All right. Thank you.
Welcome.